Okay, so it should the breaker should also not cause over voltages during switching. It's because that if this the current, as I said, that when it can you see the screen?
Yes, sir.
Yes. So when this current is actually switched, it's normally switched in during the current zero crossing. So during this point, so these are the points what we called current zero crossing. So this is our current I of t, of course, and this is time t. And after in a 50 hertz system, after each 10 millisecond, you have the current actually crosses this x-axis, or there is a point momentarily when your current is zero. So circuit breakers are normally designed normally the circuit breakers actually interrupt the current exactly at current zero crossing, because at that time you do not have any current flowing through the contacts. So circuit breakers actually interrupt the current here. But for some reasons, if it is too good, if the breaker is too good than what it needs, so it will cool the arc even when you have a certain amount of current flowing through the line. And it may happen that instead of zero crossing, so instead of this point, the current is probably interrupted here. So it may come to this point and then suddenly it goes to zero value. So if it, I mean, this particular phenomenon is called current chopping. So it's called current chopping because the current is actually being chopped here. So this is called current chopping, CHOPPING. So this is called current chopping. So if you have a current chopping, then basically as you have inductor in the line, as you have inductor L, and if the current here, the current I which was flowing through this line gets suddenly chopped, that means you have a high di over dt. And because of this high di over dt, you know that the voltage developed across the inductor is L di by dt. So as di by dt is very, very high because of this current chopping, you will generate a over voltage across this inductor. Am I clear? আমি কি বুঝতে পারতেছি?
Yes, sir.
Yes. So your circuit breaker should be designed in such a way
Yes, sir.
that that is ideal for the network. So if the network needs a if the network needs a medium quality circuit breaker, then you should not place an excellent graded circuit breaker in the system. That will also cause problem. Okay. What else we have here? We have the switching arc. I tried to explain it, what happens here when you have a transition in the temperatures. So you can go through. So this is what you have inside the arc. So inside the arc, you have two electrodes. One is cathode and another is an anode. So cathode is the negative part, or the part connected with the negative terminal. Anode is the positive terminal here. And then you have the arc. And in the first stage here, there is a very small distance connected with the cathode, is called a cathode a cathode voltage drop region. That means this particular area will have a fixed amount of voltage, as you can see in y-axis it has voltage, and in x-axis this is the gap length. So this is the exact length coming out from here. This one is here. So within this very short distance, you have a high voltage drop here near to cathode, as you can see. So this part of the region is called cathode region, and this part of the region is called anode region. So in the anode region, you have also a high voltage drop within a very short amount of distance, and the rest of the part is called arc column. So this is called arc column, and it has a relatively less slope. That means the amount of voltage across amount of voltage in per unit distance is relatively small here in this portion. So this is what you have inside the arc. Now, using these principles in medium voltage breakers, normally this principle is used where the intention is to make the arc voltage higher, and this is done by intentionally having a lot of parallel arcs. So you intentionally force the arc to flow through different slits. So you have very small arcs burning between each of these small slits so that the arc voltage increases. So the arc voltage is the voltage across the arc. This can go high because of this slits. A lot of slits you have. Within each slit, you have a fixed voltage drop because of each slit has a certain cathode and anode drop. So each slit will have a certain voltage drop, and as they are burning in series, so they adds up, and you have a relatively high amount of arc voltage coming out from these slits. And this technique is actually used in low voltage circuit breakers. So if I show you low voltage circuit breakers, so inside the low voltage circuit breaker, this mechanism is used. Okay, so inside this low voltage circuit breakers, as you can see here, you have these slits. So the arc actually burn inside the slit here, like here. As you can see, there are many parallel slits, and the arc actually burns inside the slit like this. And within each plate, you have a fixed amount of voltage drop, and as these are connected in series, so the arc actually burns connected in series, resulting in a high arc voltage, which actually helps in interrupting the current. আমি কি বুঝতে পারতেছি? Am I clear, or things are difficult for you to understand?
Yes, sir.
Yes, sir.
No, you are clear, sir.
Okay. But for higher voltage levels, we normally have a different medium than air. So when the voltage levels are low, that means in household level, we have in household applications, we have the voltage level of 230 volts, or in three-phase system that will be 400 volt. That is relatively low voltage. But if the voltage gets higher and higher, in transmission level, it's 132 kilovolt in Bangladesh, or 230 kilovolt. So these are very high voltage. In high voltage system, you need to have different material than air, or different mechanisms needs to be there to interrupt the current, because the interruption will be more difficult as the voltage is higher as well as the current is high. So to do so, there are many different techniques exist. One of it that was used in the past a lot, nowadays is not used. I mean, nowadays it's being used, but no new circuit breakers coming out from oil is being used. So it's only those circuit breakers based on oil that are in use. Those has been installed many years ago and still in service. So it's needed for us to know about oil circuit breaker, because many of these oil circuit breakers are still in the grid and they are under operation, but no new oil circuit breaker are actually being installed nowadays. Okay, so inside the oil circuit breaker, you have basically oil as the interrupting medium, and basically the oil interrupts the current. So everything here, everything is submerged in oil. So you have a tank, and inside the tank you have inside the tank everything is submerged in the oil, and you have a moving contact and you have a fixed contact. So when the moving contact is the contact that has a spring connected to it, so when you give the circuit breaker the command to open, so this moving contact actually moves away from this fixed contact and you draw the arc here. So the arc actually burns in between. Okay, and in the oil circuit breaker, you create a mechanism where the oil actually flows inside this arc to take out the heat from the arc and extinguish the arc. Okay, so oil is basically hydrocarbon. So you have hydrogen, you have uh, carbon, and basically hydrogen and carbon. So this when you have an arc, so this hydrocarbon basically this hydrogen from hydrocarbon chain, you have a hydrogen atom. Now this hydrogen has a very good current interruption properties. So this hydrogen gas which surrounds the arc helps in the interruption process. So within this arc, this hydrocarbon will break down and then form into hydrogen, and this hydrogen actually helps in extinguishing the arc, as well as you create some mechanism so that the oil can actually flush through these slits to take out the heat from the arc to extinguish it. There is another technique which is called air blast circuit breaker. So here you basically have the blast of cold air to take out the heat from the arc. So the blast can be axial or it can be radial. So axial and radial means that if the flow of the blast is this way, that means we call it axially, because this is the axis. So this is the axis, and if the flow flows through the axis, then we call this axial flow. It can be radial flow. So the radial flow is like this. So this is the axis, and perpendicular to it, if the flow generates perpendicular to it, then it's called radial flow. So air blast circuit breaker is actually uses air to interrupt the current, but using a blast of high pressure air to interrupt the current. You have sulfur hexafluoride or SF6 circuit breakers. So this SF6 circuit breaker is again, you have fixed contact, you have an arcing contact here, and when they open, the gas, SF6 gas surrounding the circuit breaker is actually being forced to flow through here, and this SF6 gas actually takes out the heat, and then it cools the arc. Am I clear? তোমরা কি কানেক্টেড আছো?
Yes, sir.
Okay.
Yes, sir.
So you have in the SF6 breakers, you have a a mechanism called puffer. So you can see that you have a puffer chamber here. So it's like a syringe. So when this contact actually moves in this direction, so this part actually gets compressed. So this part actually gets compressed because you have a piston here. So this piston is fixed, and when everything actually the moving contact moves, then this area gets compressed and the SF6 from this area actually flows inside the arc and it extinguishes. This is how the sulfur hexafluoride based circuit breaker actually works. You have another breaker which is called vacuum circuit breaker. So vacuum breakers actually uses the vacuum medium to interrupt the current. So inside the vacuum medium, when this two contacts separates, you have an arc, and at current 0, as there is no more current flowing through the vacuum, it can interrupt the current if the medium is vacuum. So vacuum medium uses vacuum as the interruption medium, but inside the vacuum medium you have two problems. One is you cannot increase the voltage for the circuit breaker to a very high value. That means if you need for transmission levels, you cannot use vacuum circuit breakers. And the other problem is that in the vacuum circuit breakers, if in the vacuum circuit breakers you have this problem with current chopping. That means that instead of current 0 crossing, the current instead of current 0 crossing, so in normal circuit breaker it would have a current 0 crossing, but vacuum breakers have a tendency to shut down the current before current 0 crossing, and it generates an over voltage. Okay, so that's it for today. I'm not going to make it any more longer, but it's your task to go through after chapter 4.5. It's not a, I mean, it's not a lot of things here, but you should know about the different breaker technologies, and I will provide few numerical problems on the calculation of this current chopping. So if you have a current chopping, then in what happens, and some numerical problems based on this calculating of arc voltage and arc energy inside the arc. So the arc energy is basically arc voltage multiplied by arc current, and then if you integrate it, this is the VI is the power. So if you integrate over the time, then you will find the arc energy. Okay, so I will provide it by today, few numerical problems. Your task is to go through the text here and do the numerical problems, because these are important for you. Am I clear?
Yes, sir.
Okay, so if you have any question, you can ask me. Or আমার ক্লাস কি বোঝা যাচ্ছে in general?
Yes, sir.
নাকি ডিফিকাল্ট লাগতেছে এখন পর্যন্ত?
স্যার বোঝা যাচ্ছে স্যার।
ওকে, সো তোমাদের আপনাদের মেইন টাস্ক হচ্ছে মিডের জন্য চ্যাপ্টার 1, চ্যাপ্টার 2 এবং চ্যাপ্টার 4 এই বইয়ের। হ্যাঁ, সো ইউ হ্যাভ টু ফলো দিস বুক, and then on top of that I will give you few numerical problems that you need to find the solution, and these are needed for exam. Okay, so that's it for you for today. If you do not have any question, I will close this session. If you have any question, feel free to ask me.
স্যার রেকর্ডিং গুলা কি স্যার পোস্ট করা যাবে ক্লাসরুমে?
Sure, I will upload the recording by today, inshallah. So আজকের মধ্যে ইনশাআল্লাহ আমি এখনই রেকর্ডিং গুলো সব আপলোড করে দিচ্ছি।
থ্যাংক ইউ স্যার।
Okay, thank you very much. Anything else?